The universe is a vast and mysterious place. It's filled with billions upon billions of stars, each with its own story to tell. Stars are born, they live, and they die. It's a cycle that has been repeating itself for billions of years. We can think about the life of a star like a human life. Stars are born from clouds of gas and dust. They grow and mature, shining brightly for millions or even billions of years. But eventually, even stars reach the end of their lives. But the end of a star's life is not always the end of its story. Some stars, like our own sun, will go out with a whimper, transforming into something new. These stellar remnants, called white dwarfs, offer a glimpse into the future of our own solar system and the universe beyond. As a star like our sun ages, it begins to run out of its primary fuel, hydrogen. Hydrogen is the element that powers the nuclear fusion reactions at the star's core, the source of its energy and light. When hydrogen runs low, the star's core begins to contract and heat up. This heating causes the star's outer layers to expand dramatically, turning it into a red giant. Red giants are truly enormous, sometimes hundreds of times larger than their original size. If our sun were to become a red giant, it would engulf the orbits of Mercury, Venus, and possibly even Earth. During this red giant phase, the star's core continues to contract and heat up, eventually becoming hot enough to fuse helium, the product of hydrogen fusion. This helium-burning phase is relatively short-lived, and once the helium is exhausted, the star's fate is sealed. With its nuclear fuel spent, the red giant can no longer support its own weight. Its outer layers, consisting mostly of hydrogen and helium, drift off into space in a beautiful, expanding cloud known as a planetary nebula. These nebulae, although named for their resemblance to planets in early telescopes, are actually the remnants of dying stars. At the center of this expanding cloud lies the star's core, now incredibly dense and hot. This core, no larger than the Earth, contains a mass comparable to that of our sun. This incredibly dense object is a white dwarf. White dwarfs are incredibly hot when they first form, with surface temperatures exceeding 100,000 degrees Celsius. This intense heat causes them to glow brightly, hence their name. However, unlike normal stars, white dwarfs no longer produce energy through nuclear fusion. They are essentially embers left over from a once mighty fire. Over billions of years, white dwarfs slowly cool down, radiating their heat out into space. As they cool, their luminosity decreases, and they slowly fade from white to yellow, then to red, and eventually to black. This cooling process is incredibly slow, taking billions upon billions of years. In fact, the universe is not yet old enough for any white dwarfs to have cooled down completely. Section 5. Black Dwarfs, Cosmic Ghosts of the Future. The theoretical endpoint of a white dwarf's evolution is a black dwarf. Black dwarfs are hypothetical objects, essentially dead stars that have cooled down to the point where they no longer emit any significant heat or light. They would be incredibly faint and difficult to detect, essentially invisible to our current telescopes. However, as mentioned earlier, the universe is not old enough for any black dwarfs to have formed yet. The cooling process for white dwarfs takes so long that even the oldest white dwarfs in the universe are still radiating heat and light. Black dwarfs represent the final stage in the life cycle of many stars, a cosmic graveyard where stellar remnants fade into obscurity. Section 6. A timescale beyond imagination. The vastness of space is matched only by the vastness of cosmic time. The processes we've discussed, the life and death of stars, the formation of white dwarfs and their eventual cooling into black dwarfs, occur over timescales that dwarf human comprehension. Billions of years are needed for a star like our sun to exhaust its fuel and transition into a white dwarf. Billions more are required for that white dwarf to cool down completely. These timescales are so immense that they challenge our very understanding of time itself. Yet, these processes are happening all around us, throughout the universe, as stars are born, live, and die in a never-ending cycle of cosmic renewal. Section 7. White dwarfs and the secrets they hold. White dwarfs, though small and faint, are incredibly interesting objects to astronomers. They represent a stage in stellar evolution that our own sun will experience billions of years from now. By studying white dwarfs, we can learn about the future of our own star and the processes that govern stellar death. Moreover, white dwarfs can be used to estimate the age of star clusters and even galaxies. Since all the stars in a cluster form at roughly the same time, the coolest and therefore oldest white dwarfs in a cluster can provide a lower limit on the cluster's age. These stellar remnants hold clues to the history of our galaxy and the universe beyond, offering a glimpse into the far future of stars and the cosmos. Section 8. The Fate of Our Sun. In about 5 billion years, our own sun will begin its transformation into a red giant. It will expand dramatically, engulfing the inner planets, including Earth. As a red giant, the sun will shed its outer layers, creating a planetary nebula. At the center of this nebula will lie the sun's core, a newly formed white dwarf. This white dwarf, once the heart of our solar system, will slowly cool down over billions of years, eventually fading into a black dwarf. Though our sun's life as we know it will come to an end, its transformation will enrich the interstellar medium, providing the building blocks for future generations of stars and planets. Section 9. The Ever-Evolving Universe. The universe is in a constant state of change, with stars being born, evolving, and dying in a continuous cycle. White dwarfs and their eventual fate as black dwarfs are simply one chapter in this grand cosmic narrative. As we continue to explore the universe, we will undoubtedly uncover even more fascinating objects and phenomena that challenge our understanding of space and time. The study of white dwarfs and other stellar remnants provides a glimpse into the future of our own star and the universe itself, reminding us of the vastness of space and the wonders that await our discovery.